Greetings, coders. In this video, we are going to look at implementing using the array to implement the min heap. So let's go back to our original example where we inserted 14 into the heap, but we had this tree. And we still have the tree, but it's implemented within the array. So we can see the array over here as well. And if you take the topmost item, 12, its two children are 2 and 3. If you take the next level at 21, this is index location 2. The children are at 4, 24, and 5, 31. And this just continues all the way down through the rest of the heap. Everything else remains the same. The difference here is instead of having links for these, we're using calculations to figure out the children and to get back to the parent when necessary. Okay, so let's add 14. We go to the very bottom most element and add it at the bottom of the tree. It turns out that this is array location 11. As we can see here, this is 11. It's pointing at 11. Now we check, is 14 less than the parent? It is less than the parent, so we're going to swap. And we've now moved up to 5 for 14, and 31 has been moved down to index 11. Next, we check 14 against 21, 14 against 21. And 14 was less than 21, so we swap again. And so now 14 is at index 2, and 21 is at index 5. 14 is greater than its parent. So we are done with the percolating step, and that's it. We now have added a new item and have reasserted the heap's order property. We do the same thing with after deleting the minimum, follow the same process. We remove the minimum, we move the last element to the root, and then we reduce the size of the heap. And then we adjust the heap to maintain the heap order process by adjusting or moving that root value down until it fits. So we delete the minimum 12, it's gone. And we take 31, we move it to the top. So it's now at index of 1. And we no longer have this last value. We find the smallest child of 31. So we have 14 and 16. It picks 14. That's the smallest. We then swap 14 with 31. So we now have 14 is at index 1 and 31 is at index 2. Now we check the smallest for 31 against elements 4 and 5. So 24 and 21. We take the smallest, which is going to be 21. And then we swap 31 and 21 because 21 was less than 31. And so now 31 is moved down to index 5 and 21 is at index 2. We find the smallest child of 31. 32 is the smallest, but 32 is not smaller than 31, so there's no swap. And we have our heap order. That's it for this video.